is protolith? Anyone? Yes. So protolith is basically the source rock from which, or the source rock which has undergone the metamorphism. Okay, that is the protolith. So in like metamorphism, you know about the basic rocks. Okay, basic igneous rocks. So the metamorphic phases you commonly study, that your prehenite, pompelite, geolite, greenschist, okay, amphibolite, granulite, eclogite, blue schist. These are like basic protoliths. Okay, these are all basic protoliths. You are studying it from the graduation time, the metamorphic phases. So that is the progressive metamorphism of basic protolith. Okay, you know, like from geolite to then it goes to prehenite, pompelite. Okay, then it goes to your green cyst, then amphibolite is then granulite is then blue cyst and eclogite. Okay, eclogite. So this is the basic progressive metamorphism of which one? Basic protolith. Okay, but accordingly, for paletic protolith will be different. For calcareous protolith, that will be different. Okay, that we will be studying. Okay, so for basic protolith, the simple thing is we have to study the metamorphic phases. The classic, the general metamorphic phases. You know that the diagram. Na, this diagram you have studying it from your BSc times. Okay, from graduation times. This is the basic diagram of basic protolith. Okay, this is the general thing you already have known, familiar to these things. So that's why we are studying this metamorphic phases concept. After that we will study about the paletic and calcareous protolith. Okay. So metamorphic phases is given by Penty-Escola. Penty-Escola, but when he given that, there are almost 5 to 6 phases. Okay, after that, your Goldsmith changed the metamorphic phases, this diagram, and given this diagram that we are studying today, that is given by Goldsmith. But the father of phases, metamorphic phases, we can say as Penty-Escola. Okay. So metamorphic phases is distinctive assemblage of minerals that represent particular temperature and pressure. Okay, at particular temperature and pressure. So first of all, tell me why metamorphism happens. Tell me why metamorphism change to recrystallization of rocks for change in pressure. Not always recrystallization. Okay, so basically you can say the fact due to the fact that um, the rocks, okay, the rocks, either they may be igneous or sedimentary. Okay, they are formed. They are formed in a particular PT condition, in a particular, you can say, geochemical conditions, geophysical conditions. Okay, geophysical conditions. Now, all the rocks formed in a particular geochemical geophysical conditions. When these condition changes, then what happens? Metamorphism happens. Simple thing. When the original condition in which the rocks are formed are changed, metamorphism occurs. Hmm? Simple. Okay, like you born in India. Okay, you born in India. Now you will go to Africa. What will happen? Your skin will be like, you will feel very हॉट, योर स्किन विल बी, यू विल लाइक ऐसे कि फील होगा कि तुम्हारा स्किन जल रहा है, और धीरे धीरे क्या होगा, तुम काला होते जाओगे। नहीं, दैट इज मेटामॉर्फिज्म. Like you will now go to the Arctic region, so the environment changes, so you will be become more fair, and you will be like fast. पहले पहले क्या होगा, तुम लोग ठंड को सह नहीं पाओगे, पूरा बुखार बुखार हो जाएगा पूरा, धीरे धीरे बॉडी एडजस्ट करेगा. ठीक है, दैट इज मेटामॉर्फिज्म. द ओरिजिनल कंडीशन व्हेन चेंजेस, the rocks are like adjusted to the new PT conditions. Okay, new PT conditions, that is called as metamorphism. Okay, so when particular temperature pressure changes, what happens? The mineralogy also changes. Okay, the mineralogy also changes. Recrystallization occurs, structure changes, texture changes. Okay, everything, like everything changes. Okay, everything change takes place. So that thing is addressed by basically the mineralogical thing. The mineralogical thing is addressed by facies. Okay, facies, or you can say the progressive metamorphism of peritic and calcareous rocks. These are addressed. They address the change in mineralogy. Okay. So in case of metamorphic facies, this thing is for basic protolith. When undergo basic rocks, when undergo metamorphism, these phases are take place. Okay, these phases take place. So next we are going to the faces. So this is the basic diagram of the faces. So it's up to you that you study this from this side or from this side. No worries. Okay. मेरा क्या, मेरा हाँ, ये ऐसा है कि मैं ऐसे डायग्राम में से ये कलेक्ट किया हुआ है, इससे आर्ट मटेरियल से मैं ऐसे ड्रॉ करता हूँ. ठीक है, आई ड्रॉ लाइक दिस. सो दिस इज the contact series, this is the medium PT, and this is the high PT. Okay, eclogite, blue cyst and eclogite. This is geolite, prehenite compellite, your green cyst, amphibolite, granulite. Okay, and this is your hornblende hornfels, albite hornfels, albite hornfels, hornblende hornblende hornfels, and sanidinite hornfels. Okay. So this is the diagram. You can draw like this, and you have to remember these PT conditions. Okay, these temperature pressure conditions you have to remember. Okay, these values about these phases. Okay, about these phases only, because phases is a very like wide concept. So questions come from this thinking how much pressure and temperature is there for granulate phases, amphibolite phases. These type of questions are asked in the interview. Okay, I have faced that question, or at least I have asked, no, I am asked this question, what is the temperature pressure of granulate phases? Sir, I don't know, sir, particularly. So that's the thing. So first, see the albite. If we will see the contact series. Okay, the contact series means this series. Okay, this series. This series when happens, when there is a intrusion in the country rock. There is a intrusion in the country rock. The typical texture is Hornfels texture. You have seen the Hornfels texture. So this is the contact series. The contact series happens when takes place when then there is a intrusion. Okay. So albite epidot Hornfels is the low contact series. Hornblende Hornfels, pyroxene Hornfels, sanidinite Hornfels. So can you say this is the country rock? Okay, this is the country rock, and this is the intrusion. Okay, this is the intrusion. This is the intrusion. Okay, can you say? which phases will take place in this region, that is the closest to the intrusion, and which phases will take place in the like farthest to the intrusion. Yes, that's the thing. So cyanide hornfels will be the closest to the intrusion because it is the high temperature metamorphism. Okay, cyanide hornfels. Okay, that is the thing. So albite hornfels is the low temperature hornfels species, and this happens that it takes place generally farthest from the intrusion. Okay, farthest from the intrusion. It generally takes place at 450 degrees Celsius, and pressure is less than 2 kilobar. You can exclude the pressure also. Okay. So what is the characteristic? It develops outer fringes. Okay, outer fringes like this type of fringe is developed in albite epidot hornfels. Okay, this type of fringe like a zone. Okay, like a zone where only albite epidot hornfels you can find. Okay, so characteristic mineral assemblage is albite and epidot, you can say that much is enough. Okay, so it is roughly like uh, the high temperature equivalent of green cyst facies. Okay, green cyst facies, high temperature equivalent of green cyst facies. Green cyst facies, you know the index minerals, tell me. Yes. So the index minerals are chlorite, albite, epidot. Okay. For the green cyst facies, the index minerals are chlorite, albite, and epidot. So you see, albite and epidot is here. So albite and epidot Hempel species is called as the high temperature equivalent of green cyst facies. Okay. Next, temperature increases. We are going to the Hornblende, Hornfels. Okay, Hornblende, Hornfels. So here is this. There is a table. This is collected from the earth materials books. Earth material books. Okay, earth materials. So here you can see that proton can which type of mineral in this contact metamorphism series. Okay, pelitic will form the if pelitic protolith undergoes contact metamorphism, then in albite epidot Hornfels facies, then what type of mineral will be the result? Getting it? If pelitic protolith undergoes contact metamorphism in albite epidot Hornfels facies, then what type of mineral will form? What will be the mineral assemblage? This is written here. Okay, you just look, have a look over it. This is not recommended to be memorized. Okay, इसको याद रखने की कोई भी जरूरत नहीं है. ओके, ये आईआईटी जाम बच्चों के लिए है. आईआईटी जाम में कभी कभी एक आधा क्वेश्चन आ जाता है, कभी कभी आता है, ठीक है, तो हमेशा नहीं आता, कभी कभी आता है. So particularly we will be studying these things, pelitic, calcareous. Yeah, this thing will be we'll complete in the next slides. Okay, coming slides. So next is your Hornblende Hornfels species. Okay, Hornblende Hornfels species takes place generally for 52 to 600 degrees Celsius, less than 2.5 kilobar, and the index minerals are, like you can say, Hornblende is the index mineral. Okay, and okay, this is the low pressure equivalent of amphibolite facies. Okay, amphibolite facies, low pressure. So, ji, albite epidot Hornfels is the low pressure equivalent of green cyst, not low temperature, low pressure equivalent of green cyst. So, this Hornblende Hornfels is also the low pressure equivalent of amphibolite facies. Okay, in the amphibolite facies, you know the index minerals, that is hornblende and plagioclase. Okay, hornblende and plagioclase. So this hornblende hornfels series also contains some albite. Okay, also contains some chloride. Okay, so amphibolite facies, the hornblende hornfels facies is the low pressure equivalent of amphibolite facies. This is the contact metamorphism series, second stage of contact metamorphism, that is hornblende is formed. Like this is the table. Like for which protolith, which minerals will be formed. Next is your pyroxene hornfels. Okay, it will be the low pressure equivalent of granulite facies. Okay, granulite facies, because granulite facies contains OPX plus CPX, na, plus plage. So these things are included in granulate facies. The pyroxene hornfels is the low pressure equivalent of granulate facies. Its temperature is like 600 to 800 degrees Celsius. Pressure is less than 2.5 kb. Okay, this is the thing. Not much to be written like in these things. Okay, just small thing. Contact metamorphism is not much important. So this is the table of the protoliths. You just go through, just have a look when I will upload the PPT. Then sanidinite hornfels facies. So sanidinite hornfels facies is greater than 800 degrees Celsius and 2.5 kilobar to less than 2.5 kilobar and less than 8 kilometer depth. Okay. So these are basically associated with sanitite. Sanitite phases are basically associated with basic and ultra basic intrusions. Why? In the basic and ultra basic intrusions, that's where only you can find greater than 800 degrees Celsius temperature. Because the acidic magma temperature is what? Like 1000 to 1100 degrees Celsius. So when they will intrude, they will give a temperature like 500 to 600 degrees Celsius. After that, they can release not much of latent heat. Okay, they have latent heat of almost they can raise the temperature almost to 500 to 600, max to max 700. Okay, because they don't have much heat content, na, acidic magmas. So basically basic magmas have temperature like 1600 degrees Celsius, 1700 degrees Celsius. So they can release high amount of latent heat, where the country rock's temperature can increase up to greater than 800 degrees Celsius. Okay, so sanidinite facies is basically associated with basic to ultra basic intrusions. Okay, this thing is to be remembered. Intrusion. So sanidinite facies is associated with basic to ultra basic intrusions. Okay, so these are the contact metamorphism series. Anyone having any doubts up to this thing? Regional metamorphism. Okay, the regional metamorphism. So first, what happens? Of the regional metamorphism, just geolite facies forms. Okay, geolite facies forms. In this geolite facies, like all the clay minerals, geolite minerals, clay minerals, chlorite group of minerals. Okay, these things actually form in case of this geolite facies. Okay, you can, it is like the uh, last stage of operation products. Okay, these are geolite facies. Sorry. Geolite facies is the alteration product, not like it is the not the in signature of starting of metamorphism. Okay, so geolite facies contains like all the geolite group of minerals and clay minerals like lomonite, montmorillonite, epidote. Okay, it also contains some amount of pompelite, prehenite, okay, muscovite chlorite, or clay group of minerals. Okay, these are included in geolite facies. So its temperature is between 150 degree to 300 degrees Celsius, and pressure is less than 5 kilobar. Depth is less than 15 kilometer. Okay, you need not remember. You need not to remember this depth. You just memorize this like temperature and pressure. Okay. So these are the zeolite facies minerals. So now what happens after the increase of temperature and pressure? Increase of, this is the table you will just go through. Okay. After the increase of temperature and pressure, what happens? The lomonite, okay, the lomonite and the chlorides. Okay, chlorides, they are like converted to prehenite. Okay, in the lower prehenite, like lower prehenite pompelite series. Okay, facies. So basically, what I am telling about the lower, you can just imagine this thing. Like when I am telling lower green cyst, okay, lower green cyst and upper green cyst. Okay, upper green cyst. So if the temperature is like 10 to 20 degrees Celsius, okay, you can imagine that up to 5 degrees Celsius, this is lower facies, and after 5 to 20, this is upper facies. So this is signified by lower green cyst facies and upper green cyst facies. This is the thing. Like मैं बोल रहा हूँ कि पहला हाफ तुम एक मेटामॉर्फिज्म एक फेसिस हो रहा है, मैं मतलब उसका कुछ रेंज है, प्रेशर टेम्परेचर का रेंज है ना, नहीं? तो आधा के नीचे जो रेंज है उसको मैं लोअर बोल रहा हूँ, और आधा के ऊपर जो है उसको मैं अपर बोल रहा हूँ. ओके, so don't be confused. So in case of the lower prehenite pompelite facies, there is no pompelite. Okay, only prehenite is there, that is transformed from the geolite facies. Okay, so temperature above 250 degrees Celsius and depth 3 to 5 kilometer depth. Now this after in the upper prehenite pompelite series facies, what happens? This prehenite converts to pompelite. Okay, prehenite converts to pompelite. Not like all prehenite converts to pompelite. There is almost presence of some prehenite. Okay, so you can say that lower green cyst facies contains prehenite, lower prehenite pompelite facies contain only prehenite, and upper prehenite pompelite series facies contains pompelite. Okay, pompelite minerals. So basically, the whole facies is called as prehenite and pompelite facies. Okay, so this is the thing. We just go through these tables. I am like from the next slides, I will be skipping these tables. Okay. Next is your green cyst facies, generally from 350 to 550 degrees Celsius, pressure 3 to 10 kb, 10 to 30 kilometer depth. Okay, and associated with dynamothermal metamorphism, that is you can call regional metamorphism. So what happens in this like green cyst facies? This green cyst facies from prehenite pompelite to green cyst facies transition. Green cyst facies transition is sharp. Is sharp, very sharp. Sharp means when this transition occurs, na, there is no signature of prehenite pompelite. In every facies, like in the granulite facies, you will get a signature of amphibolite facies. In eclogite facies, you will get a signature of blue cyst facies or granulite facies. In prehenite pompelite, you can get a signature of lawson, geolite. But in case of green cyst facies, you will not get any signature of prehenite and pompelite. Okay, that is due to like many factors. Okay, that is due to like many factors, like in a circulating hydrothermal system. Okay, there may be a present of a circulating hydrothermal system. Okay, this thing what it does, it like helps to increase the reaction, accelerate the reaction. So that's why prehenite pompelite directly converts to green cysts. Okay, in this prehenite pompelite to green cyst, what happens? The pompelite and the chlorite. Okay, in prehenite, the chlorite is coming from the geolite facies. Okay, chlorite is the clay mineral. Okay, chlorite is the clay mineral. Chlorite is a clay mineral. Chlorite is coming from the prehenite pompelite. Sorry, geolite facies series. Geolite facies. So it comes to prehenite pompelite. Then it comes to green cyst. Okay, I am like writing now then in a short, then we will go through the PPT. Okay. So green cyst, in this green cyst already chlorite is there. Already chlorite is there, and this pompelite reacts with another mineral. and gives the albite component is also coming from this prehenite pompelite. Okay, sorry, geolite, albite component. So this pompelite reacts with pompelite reacts and it gives chlorite albite epidote. Okay, epidote. It gives epidote. Pompelite reacts and it gives epidote. This forms the green cyst facies. Okay, the particular reaction will be written in the PPT, or if there is no reactions written, I'll be adding this. Okay. So chlorite, albite, epidote. So chlorite and albite is from the geolite facies, comes from the geolite facies. After prehenite pompelite, they will come to the green cyst facies, and epidote is formed from the pompelite. Okay. After that, what happens? From green cyst to amphibolite transition occurs. Amphibolite. So in this green cyst to amphibolite transition, what happens? This albitic component in green cyst becomes more calcic. Okay, more calcic. Like albite will become labradorite or bitonite. Okay, so amphibolite. After that, what happens? Amphibolite also contains what? Hornblende. So from this epidote and chlorite reaction, hornblende is formed. Hornblende is formed. So from the epidote and chlorite, they react and hornblende form. Hornblende and plagioclase. More calcic plagioclase, high calcic. This is the signature of amphibolite facies. Okay, this is the signature of amphibolite facies. After that, what will happen? Pressure and temperature will again increase. After the increase, the hornblende will break. The hornblende will break. Hornblende will break to OPX plus CPX plus water. Okay, plus water in granulite phases. In granulite phases. Okay, in granulite phases. Now, granulite phases is an interesting phases. Why? Because, like this is the first phases in regional metamorphism which has no water. Okay, no water. Why? There here water is forming. Water is forming here, na? But no water in granulate phases. Why? Can anyone tell? Asking, na? We are getting water from the decomposition of disintegration of hornblende, but granulate facies is a anhydrous facies. Why? Because you see that granulate facies it at the end is at the end of this thing. Okay, here temperature is very high. Temperature is very high. Now the thing is the rocks which are already in high pressure and temperature, they are getting water. They are getting water. Now water, what it will do? It will decrease the melting temperature of the rocks. It will decrease the melting temperature of the rocks. Now what will happen? That partial melting will happen. Partial melting will happen. Okay. So now the thing is the rock which has reached granulite facies, if the granulite facies have high water content, then the rock will be converted to migmatite. Okay, migmatite. Because due to high presence of water, that water will decrease the melting temperature of the rocks, and that water will be used in the formation of partially melted rocks or in the process of anataxis. Okay, so the water will be used there. That's why granulite facies is a anhydrous facies. Okay, all the water are used in the formation of migmatite. The rocks are partially melted. The lighter portions are melted, and the darker portions are less melted. That's why it is like not all much of things are melted. You have those who have in those who are in the institute, they can see the like they can see our museum, rock museum. In the upper portion, upper shelf, all the folds you have seen, these are all migmatites. Okay, folded, they are flow folds, they are all flow folds. You can see in our institute, the upper portion, upper shelf, the upper shelf is full of like big rock samples that are all migmatites. Okay, in that migmatites, what happened, like in migmatite, the whiter portions, that are the felsic portions, the darker portions are the basic portions. The felsic portions have low temperature, the basic portions have high temperature. So when partial melting will occur, the felsic portion will melt first, but the basic portion will remain solid. Now the as the felsic portions have melted, they will start flowing. Okay, they'll start flowing. After the flow, they generate folds, flow folds. Okay, they are not structural folds, they are flow folds due to the flowage of the liquid. Okay, so these felsic portions flow and form folds, and accordingly the basic portions arrange themselves in the folds. Okay, now this, if this is the rock, all the felsic portions will be melted, and due to the presence of water, they will be partially melted, and then they will be start flowing. They will like ऐसे वो flow करेंगे कैसे भी करके. Okay, complex folding लेके कैसे ही flow करेंगे, and they will form these folds, and the basic rocks will accordingly arranged here. Okay, accordingly arranged here, basic portions of the rock. Okay, so these whiter portions are called as leucosome, leucosome, and these are called as melanosome. Okay, these darker portions are called as melanosome, whiter portions are called as leucosome. Okay, now this is the thing. In granulite phases, migmatization, or you can say anataxis process takes place. All the waters formed from the decomposition of hornblende is used to form this, used to continue the process of this partial melting. If there is no hydrous condition, if there is very less amount of water, or you can say after the formation of migmatite, the rocks which have remained, or remainder rocks that will be gone to like blue schist or eclogite, blue schist or eclogite. That depends on the temperature and pressure conditions. Okay, that depends on the temperature and pressure conditions, that granulite will form eclogite, or granulite will form blue schist. Like the blue schist can be formed directly from prehenite pompelite. Okay, prehenite pompelite, green schist, and granulite, Okay, blue schist can be formed from here directly. Okay, and the eclogite facies can be formed from anywhere, like from prehenite pompelite, or from green schist, or from amphibolite, or from granulite, or from blue schist. Okay, eclogite can be formed from anywhere, any facies. Okay, this is the thing. Everyone getting it now? So this is the thing. Okay, now blue cyst, like in case of blue cyst, there it can form from prehelite to green cyst, granulite. There are reactions. Okay, there are reactions from which blue cyst is formed. Blue cyst contains the lawsonite, lomonite, and what are the index mineral of blue cyst? Yes, glaucophene, thank you, glaucophene and lawsonite. Glaucophene and lawsonite. Okay, but here albite is present, like you can say plagioclase is present in every single facies except eclogite. Okay, eclogite, except eclogite, eclogite is like considered as the no plagioclase facies. Okay, now in case of eclogite, the pressure is such much high, plagioclase breaks down. Okay, plagioclase breaks down. So in case of eclogite, you can say pyrop and omphacite. Okay, that is you can say garnet plus CPX. Okay, garnet plus CPX is the index mineral of eclogite, pyrrolspite garnet and omphacitic pyroxene. That is the index mineral of eclogite facies. Okay, let's go to the PPTs and see what extra was written there. And if the reaction, I think the reactions are not here, I'll add the reaction and then upload the PPT. Okay. So this is the green cyst. Key minerals of the green cyst facies include epidote, chlorite, actinolite, green amphiboles. Okay, green cystose. Yes, this is the thing. Cystose structure is first formed here. Cystose structure is first formed in green cyst facies. Okay, this thing you have to remember, that cystose structure is first formed in the green cyst facies. And another thing, the last relic texture you can find in green cyst facies. After that, you cannot find any green cyst relic texture. Okay, last relic texture you can find green cyst. Like relic texture means the texture that is inherited from the protolith. After the when the green cyst facies converts to amphibolite facies, after that you cannot find any relic texture. Okay, all the textures will be newly originated in the process of metamorphism. Okay, no igneous or sedimentary texture will be present there. Okay, so this is the green cyst facies. So green cyst facies can be subdivided into the chloride zone, biotite zone, and lower part of almite garnet zone. This is basically corresponds to the Barrovian zone. Okay, Barrovian zone. Barrovian zone is chlorite, biotite, garnet, chorlite, kyanite, sillimanite, CBGSKS. Okay, so this is the Barrovian zone. What is Barrovian zone? Anyone? Why this Barrovian zone is generated? Pelitic rocks. So when we'll be studying the progressive metamorphism of pelitic rocks, na, we'll see that the Barrovian zones are formed. So basically, the Barrovian zone is the classic example of metamorphism of pelitic rocks in Scottish Highlands. Scottish Highlands. Okay, that is in Scotland. Okay, that is in Scotland. So what happened? Barrow studied this Scottish Highland Metamorphism series, and he found that certain minerals are forming at certain temperature pressure conditions. Then he found the index minerals and called them as a zone. That's where the Barrovian zone came. Like you are studying this, the facies. You are the studying the facies, metamorphic facies for basic rocks, and this is the metamorphic facies for pelitic rocks. Likewise, the metamorphic facies for calcareous rocks. Okay, these are the things. So, in case of green cyst facies, all three zones like chloride zone, biotite zone, and garnet zone. Okay, green cyst facies. Then your amphibolite facies, temperature and pressure is 550 to 750 degrees Celsius, 4 to 12 kilobar pressure. Okay, it is found in like regional orogenic belts. Okay, yes, about the blue cyst facies, I will tell you in the blue cyst thing. Okay, So transition of green schist to amphibolite facies is marked by an increase in hornblende, garnet, anthophyllite, and a decrease in actinolite, chlorite, biotite. Rajuka become sodic and more calcic, as I have told you. Marks the appearance of storolite in pelitic rocks. Okay, so this belongs to the zone. Hello. So we are moving to the uh, corresponds with the almandine zone. Amphibolite facies corresponds to the almandine zone. Here it was written as storolite. CPG SKS. Okay. So garnet and almandine is garnet and your storolite. Storolite is included in this facies. Amphibolite facies corresponds to the garnet and almond storolite zone of Barrovian sequence. Okay. Next is your granulite facies, 700 to 900 degrees centigrade, 3 to 15 kilopar, 10 to 50 kilometer depth. Okay, mineral assemblages are OPSC, PX plus Euclides. Granulite facies minerals are predominantly anhydrous. Metabasic and meta-ultrabasic granulites commonly contain both OPX and CPX. Okay. Granulite facies rocks include migmatites. Okay. So these are already I have told you. Granuloblastic texture. Okay. Non-foliated to foliated fabric. Gneiss also develops here. Gneiss. Okay. Gneiss. The granite gneiss. Gneiss is the characteristic facies of characteristic structure of granulite facies. In case of granulite facies, gneiss will be formed. Okay. So you have known the like older granulite belts, older greenstone granulite belts. Their cyst and gneiss are there. In case of granulite, gneiss will be formed. In case of green cyst, there will be a cyst formed. Okay. So granulite facies correspond to the upper part of the Barrovian sillimanite zone. Okay, sillimanite zone. That is CPG SKS, the last zone, sillimanite zone. Granulite facies, high temperature zone. Okay. Next is your blue cyst facies. Blue cyst facies is from 150 to 500 degree. This is the low temperature, high pressure facies. 152. This is the characteristic of subduction zone. Remember this, huh? Subduction zone and only found in subduction zone. Okay, if you are finding any blue cyst facies rocks, you can say that an ancient blue subduction zone was there. Okay, it is the characteristic of subduction zone. Okay, so the characteristic minerals are glaucopene and lawsonite. The reactions are not here. Okay, I'll add the reactions, then I'll upload the PPT. You just see the reactions. I have told the thing na, that is only written there. Okay, or you can follow the winter book. This is the this PPT is made from your earth materials. You can follow the winter book. In winter book, it is written directly what are the reactions. Okay, so another thing, a substitution reaction takes place. Substitution reaction from amphibolite to granulite. From amphibolite to granulite. That is called as sormatic substitution. Sormatic Sarmakitic. Okay, Sarmakitic substitution. Because a characteristic mineral Sarmakite. Okay, Sarmakite is formed in granulite phases. Okay, characteristic mineral Sarmakite is formed in granulite phases. Okay, I will upload that reaction. So that is called as Sarmatic substitution. So you can write down in granulite phases that Sarmatic substitution takes place in this phases. Okay, it is not written here. Then your blue cyst phases. So I have already told you the path how blue cyst phases can be formed from prehnite compilite. It can form from green cyst. It can form and from granulite. It can form. Okay. Next, your eclogite phases 400 to 900 degrees centigrade, very high pressure, 12 to 25 kilobar. Okay, characterized by no plagioclase. It can form from any phases. Okay, from prehnite compilite, from green cyst, from amphibolite, from granulite, from blue cyst, from any phases, eclogite can form. If the temperature and pressure becomes very high, then eclogite phases forms. Okay. The two key minerals are omphacite and pyroxite, garnet and omphacite. No plagioclase is the characteristic property. Okay, this is the eclogite phases, and there are 2 to 3 types of eclogite phases also there. It is not written here actually. Okay, so this is the all the phases. Okay, this thing is important. You are getting all the things like in the phases, progressive metamorphism of basic protolith. This can you can write these things in progressive metamorphism of basic protolith. From you will start from zeolite and you will end in the eclogite. Okay, eclogite. So I'll modify this into a subduction zone. Then who can say where the phases will be formed? So first, what will happen? This is a subducted plate. There will be partial melting of this plate, and the magma will rise, and there will be mantle underplating. Okay, magma underplating. This underplating then creates, then goes upward through crack and creates the arc. Okay, creates the arc, volcanic arc or island arc. This is the This is your forearc basin. This is the backarc basin. Okay. If this is the continental collision, this will be the folded mountain belt, and accretionary prism is there. Accretionary prism. Okay. Now tell me which type of faces, where I can find which type of faces. I am just symbolizing the places. You just tell me. Okay, one, like your two, 3, 4, 5, okay, 6, okay, 7. Tell me one by one. See, this portion here melting occurs. Here melting occurs. So this is high temperature, and also this plate is pushing this thing. So this is high pressure also. Okay, high pressure also. So this will be eclogite. Okay, this will be eclogite. Here, here also you can see near to temperature, and also the lithostratigraphic pressure is high here. Okay, so here also eclogite phases will take place. Okay, eclogite phases near this thing too. Okay, here only the this pushing pressure, this like your ridge pull. Okay, pull pressure, and this push pressure. Okay, they are both occurring here. So this will be your blue schist facies, because there is no temperature, very less temperature, only high pressure is there. This will be your blue schist facies. Okay, near this thing, this will be the contact series. This will be the contact series. Okay, near this arc thing. Okay, arc thing, magma intrusion is taking place, so this will be your contact series. And here it will be like green cyst facies. Okay, green cyst facies. Medium temperature, medium pressure thing is there. Okay, and about the granulite, amphibolite, they will occur like here. Okay, granulite and amphibolites, they will here. Medium temperature, medium pressure. Okay, green cyst is basically a low temperature, na? So green cyst will occur here. Granulite, amphibolites will occur here. This will be the contact series. This is the contact series. This will be the contact series both side. Here contact series, here contact series. This is eclogite, eclogite, eclogite. This will be your blue cyst, particularly in the subduction area. Okay, it will be blue cyst. This will be like your low temperature zeolite or prehenite, pompelite. These things will be there. Okay, everyone getting it? Why I have told these things, like these will be these faces? Okay, so let's see. So this is the facies, metamorphic facies and plate tectonics. Okay, or you can say metamorphic facies associated with tectonism. Okay, metamorphic facies associated with tectonism. Likewise, if you will see, this is the Miocenic ridge. Miocenic ridge. What type of facies you expect here? Yes. So here it will be a contact metamorphic region. Okay, here it will be a contact metamorphic region. Okay, so this thing is called as subduction zone is called as paired metamorphic belt. Why? Paired metamorphic belt. Why? Subduction zone is called as paired metamorphic belt. Why? Yes. So basically, both, you can say both regional metamorphism things and contact metamorphism things you can get. Okay, both high PT and low PT conditions you will get. Okay, in the subduction zone. That's why paired metamorphic belt is associated with the subduction zone. Okay, that this will be contact zone. Likewise, in the hotspot case, you will get the contact metamorphism series. So this is the metamorphism and plate tectonics. Okay, so let's see the diagram. That there was a diagram, na? Yes. So this is four. Like your four is eclogite. Four, four. Okay. This is your eight. What is eight? Eight is granulite. Granulite. Three. Three is your blue cyst. Okay. Six, seven, five. Six, seven, five. These are green cyst. Amphibolite. This is the six is your contact metamorphism. Okay, albite epidot amphibolite. Okay, this is the contact metamorphism. Amphibolite. Seven is your amphibolite. Five is your green cyst. Okay, these are the things. Clear? So this is the assemblage of basic protolith. Okay, basic protolith: zeolite, granite, pompelite, green cyst, chlorite, albite epidot, amphibolite, hornblende, plagioclase, granulite, OPX, CPX, plagioclase, blue cyst, glaucophenolosonite, eclogite, garnet, omphacite. Okay. Okay, about the metamorphosing facies series, that will be taught to you by Subho sir. I am just teaching you the progressive metamorphism thing. Okay. So till of calcareous protolith means the rocks with carbonates. Okay, the rocks with carbonates, or you can say limestone, dolostone, dolomites. Okay, these are the things. Calcareous photolith. When they undergo metamorphism, they will undergo like in your contact metamorphism or regional metamorphism. So basically, our main importance is contact metamorphism in case of calcareous photolith, because the contact metamorphism of calcareous photolith gives the scan scan formation, and which is the very important economic source of REs, of Fe, F of gold, okay, of tungsten, tin, zinc, okay, and the lead zinc deposit of Jawar is scan, na? Yes, Jawar is scan. Yes, maybe. Now we'll see. Okay, maybe Jawar is scan, and this is the thing. Okay, so metacarbonates are the metamorphosed calcareous rocks. Calc-silicate rocks. A skarn is a typically calc-silicate rock formed by metasomatic interaction between carbonate and silica-rich melt. Okay. About the skarn, in the metamorphic petrology syllabus, about the formation of skarn, that will be taught in economic section. Okay, that is not necessary to be taught in metamorphic section. There is a thing now, formation of skarn in metamorphic syllabus. Okay, that will be taught in the economic section. Okay. So quantum metamorphism of siliceous dolostones. So basically, there are three zones formed in the progressive metamorphism of carbonaceous rocks, in contact metamorphism of carbonaceous rocks. That is talc zone, tremolite zone, diopside or phosphorite zone. Okay, so you can say diopside and phosphorite also. You can say phosphorite zone. Four zones you can say. Okay, four zones formed in case of the contact metamorphism of calcareous rocks. Okay, again I am saying contact metamorphism of calcareous rocks forms four zones: talc zone, tremolite zone, diopside zone, and phosphorite zone. And these zones depends on what? Depends on xCO2. That means the presence of the amount of carbon dioxide. The zones and the sequence of zones. The sequence of zones is always this: trial, tremolite, diopside, phosphorite. But the which amount of zones will be there? Like there will be only talc, or there will be talc tremolite, or there will be talc tremolite diopside. So what will be the the composition of the whole contact metamorphism? That is dependent on the xCO2. That means the CO2 concentration of CO2 partial pressure, or you can say just concentration of CO2, and the system is open or closed. The system is open or closed. Open means a circulating system is there. Okay, a circulating system is there. A mineral can enter and exit. Like not in the mineral, but particularly xCO2 and water. These things can enter and exit in the open system, but in the closed system, they will remain there. Okay. So this is the thing. So what I told, like the contact metamorphism of calcareous rock is wholly dependent on the xCO2, and the system is open or closed. Okay, this is the thing. So this is the diagram you have to draw. Like don't like डरो मत, मैं सिर्फ दिखने में डरावना हूँ. ठीक है. So up to this you have to like remember. Okay, I will tell you one shortcut to memorize this thing. Okay, but not now. Not now. After you give your exam, after that I will tell you. Okay, so see here. ହଁ ସତରେ ମାନେ ସତରେ, ଆଉ କଣ ମିଛରେ ମୁଁ କହୁଛି? You have to memorize this diagram. Don't, like I told you ना, डरो मत, मैं सिर्फ दिखने में डरावना हूँ. This diagram is telling to you. Okay. So see, there are 2 points. Okay, here is one. Here is one. Okay, this basically represents XCO2 less than 0.7, XCO2 less than 0.97, okay, and greater than 0.7, and another thing is XCO2 is greater than 0.97. Okay, you are viewing this ना? देखो क्या होता है यहाँ, ये जो this region is XCO2 0.7. Okay, before this region there will be a sequence of reaction, like this is the temperature, this is the increasing temperature. Okay, this is the increasing temperature. Wait, here temperature is increasing, it will be okay. We have to read up to this only, okay, not to upper portion. So when temperature increases in y axis, and this is the XCO2 content in x axis, okay, XCO2 content. So I have told you that what minerals will be formed, that depends on XCO2. Okay, XCO2 of that mineral, ki how much of concentration of carbon dioxide is there in the system. Okay, so if this diagram, see this diagram, this is one point, this is another point. Huh? If XCO2 is less than 0.7, XCO2 is less than 0.7, then this thing will be happen, this thing. Okay, XCO2 is less than 0. Consider XCO2 is less than XCO2 is equal to 0.3. Then if you increase the temperature, these reactions will take place. Okay, these reaction will take place. This sequence will take place. If XCO2 is 0.7 to 0.97, okay, this region will be the result. Like if the XCO2 is 0.8, you increase the temperature, first dolomite plus quartz will be tremolite plus calcite. This reaction will take place. If XCO2 is greater than 0.97, these reactions will take place when you increase the temperature. This is the basic understanding of this diagram. Everyone got it? See, when 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 there are, you can see there is a dotted line and there is a straight line. Okay, there is a dotted line and there is a straight line. Okay, so the dotted line basically represents a internal buffered fluid. Internally buffered fluid means the closed system, it is a closed system. Okay, if the like if the line goes straight, this straight one, the solid line, it represents the externally controlled fluid. That means it is a open system. Okay, it is a open system, that means the pore fluid is circulating. Okay, the pore fluids are circulating. Okay, so that represents the like your closed system and open system. Closed system means no fluid is getting out of the system, but in case of open system, fluids are getting out of the system and inside the coming again inside the system. Okay, so we are going back to the diagram. See, we have first taken that 0.5 is the xco2. xco2 is equal to 0.5. Okay, now when temperature increases, what will happen? First reaction is dolomite. There is dolomite. We have started from dolomite. Now dolomite is a calcareous rock. So dolomite will react with the siliceous fluid, that is quartz. Dolomite will react with quartz and it will form talc plus calcite. Okay, dolomite will react with quartz and it will form talc plus calcite. After that, it will depend that it is a buffer system or it is a closed system. Okay, it is a closed system or it is a open system. If it is a open system, considering this is an open system, then the second reaction, what will happen? This talc form will react with calcite and quartz and form tremolite. Okay, like that, again the talc will react with calcite and form tremolite and dolomite. Okay, this is the progressive reaction with the increasing temperature. Okay, with the increasing temperature. See, first talc is formed. First, what happened? Talc is formed. We have seen that the contact metamorphism of calcareous protolith will form talc, then tremolite, then dioxide, and or phosphorite. This is the sequence. This is the sequence. So when temperature increases, if xco2 is less than 0.7, if it is an open system, then the dolomite first reacts with quartz and forms talc. Then this talc and calcite is formed. This talc and calcite will again react with quartz, that siliceous melt, and form tremolite. Again talc and calcite will react and tremolite and dolomite will be formed. Okay, we now just see this reaction. After that, I will tell how this reaction are going proceeding forward. Okay, so after you understand this diagram wholly, we will go to the theory part. Okay, so after tremolite and dolomite formed, this tremolite again reacts with quartz. Calcite is always present because this is a dolostone. Okay, this is a calcareous rock. So tremolite reacts with quartz and forms dioxide. Okay, then again tremolite reacts with dolomite and it forms phosphorite. First tremolite reacts with calcite and quartz, it forms dioxide. Then tremolite forms with dolomite, this forms phosphorite. Okay, now this tremolite again reacts with calcite at this higher temperature and forms dioxide plus phosphorite. Okay, dioxide plus phosphorite. Dioxide and phosphorite both are formed at this condition. If the system is a open system. If the system is closed system, then what will happen? This reaction is constant. First this reaction will take place, but after that directly this reaction will take place. Okay, talc dolomite plus quartz will form talc plus calcite. Then talc plus calcite will form tremolite plus dolomite. No intermediate reaction in between that. After that, the sequence is like tremolite plus calcite will form dioxide, and then it will end at this point, C point. Okay, it will end at this point. The last reaction will be tremolite plus dolomite will give phosphorite plus calcite. This is the last reaction. But in case of open system, as continuously fluid is being influxed, okay, so the reaction will continue. But in case of closed system, there is not much of fluid that is used heavily, so the reaction ends here. Okay, the reaction ends here. That is the thing. Everyone understood how this diagram works? Okay, कैसे इसको पढ़ना है डायग्राम को, कैसे बनाना है, कैसे पढ़ना है. Okay, now if the system contains 0.7 to 0.97 in this, okay, if I will consider the system contains 0.8. Okay, xCO2 is equal to 0.8. Then the first reaction will be dolomite plus quartz will directly form tremolite. Now see this difference. Now see the difference. In case of the xCO2 is less than 0.7, dolomite plus quartz giving talc. But when 0.7 xCO2 is greater than 0.7, dolomite plus quartz will directly give tremolite. One zone is skipped if the xCO2 is very high. Okay, then it will form like tremolite, again react with calcite, and it will form dioxide. Okay, it will form dioxide, and this tremolite again will form with calcite. It will form dioxide plus dolomite. Then dioxide plus dolomite will form phosphorite plus calcite. This is the reaction path. Okay. At the same time, if xCO2 is greater than 0.97, then the first thing will form is dioxide. Dolomite plus quartz will directly form dioxide. Then dioxide will react with dolomite, there will form phosphorite plus calcite. You got it? I am telling here. Okay. If xCO2 is less than 0.7, then this dolomite reacts with quartz and forms talc. Plus calcite you can write. If xCO2 is greater than 0.7 and less than 0.97, dolomite plus quartz will react and this will form tremolite plus calcite. Okay. If xCO2 is greater than 0.97, then dolomite plus quartz will react and it will form what? Directly dioxide. Everyone got it? So, metamorphism of calcareous rocks. So the assemblage dolomite calcite quartz is staple in siliceous carbonate. The first metamorphic reaction that occurs xCO2, and the temperature at which it takes place depends on the xCO2 of the pore fluid. xCO2 less than 0.7 in most situations. So the first isograde is typically dolomite plus quartz plus H2O gives talc plus what it is written. I cannot see actually my talc plus calcite plus CO2. Okay, talc plus calcite plus CO2. This thing gives. Now the reaction depends. This first reaction will take place always. Okay, dolomite plus quartz. After that, it will depend. It is internally buffered or externally buffered. Oh, that means open. Externally means open system. Internally means closed system. Okay. After that, what will happen? If we will go considering open system behavior, the straight line one. Okay, so the talc plus talc will react with calcite and it will form tremolite. Okay, it will form tremolite. Okay, the phase, actually here the phase rule works. How the phase rule works? Like what happens if you are considering this open system? In open system, CO2 and H2O are mobile, so we have not we are not consider we don't do not consider the mobile elements, mobile constituents as a phase. Na. So now here the phase number of phases are what? Your dolomite plus quartz, talc plus calcite. So there are four phases. Okay, P is equal to 4. Okay, component is equal to how much number of component? Anyone? So basically, this is calcite, this is your dolomite, this is your quartz, and this is your talc. So you have the reaction dolomite plus quartz is equal to talc plus calcite. Okay, as H2O and CO2 are in mobile phase, they are not considered as a phase or a component which भी count नहीं किया जाता. Now in this thing, CaCO3, CaCO3, CaO plus CO2, CaMgCO3, CaO plus MgO plus CO2, then SiO2 then Mg2 Si4O10 H2O. So this is MgO plus H2O plus SiO2. Total H2O and CO2 are not considered as components. CaO is 1, MgO is 2, SiO2 is 3. Okay, three components are there. They are SiO2, CaO and MgO. Clear everyone? Here component is 3, phase is 4. So and P plus F is equal to C plus 1. That is invariant point. That is invariance. Okay, degree of freedom is 0. Now if the degree of freedom is 0, the reaction cannot continue further. Okay, the reaction will occur at a particular point only. Until and unless one phase is consumed, the phase decreases to 3 and the degree of freedom becomes 1. If the degree of freedom becomes 1, then it can only proceed through a line. That's the thing. So here what happens, dolomite, in case of dolomite plus quartz, the quartz is like it ends. Okay, quartz खत्म हो जाता है. Okay, quartz खत्म हो जाता है. Why? Now the thing is, this is a open system behavior. The fluid is circulating. Okay, the fluid is circulating. The contact fluid is circulating. If now quartz is like exhausted, it can also come later because the fluid is circulating. That's the thing. Okay, that fluid will carry quartz. So now this dolomite plus quartz, okay, reaction continues until one phase is consumed. Until one phase is consumed. As dolomite is greater than quartz, because there is a huge area of your calcitic region. Now a small contact, like small intrusion is there. Small silicate intrusion is there. Now, so what will happen? Dolomite will remain in a large amount. So quartz will be exhausted first, and it is an open system behavior. The amount of quartz is first influx. The first influx of quartz is exhausted. Now we are waiting for the second influx of quartz. Okay. So the first amount of quartz will exhaust. After the exhaustion of quartz, the degree of freedom will become 1. Okay, now it will proceed further and it will wait for the second influx of quartz. Then talc will react with, then at that point talc will react with calcite and the second influx of quartz, because it is a open system behavior. Then tremolite will be formed. Okay, then tremolite will be formed, CO2 and H2O will be the products. Okay, everyone getting this? Everyone? This will form tremolite. Now the same situation is here, that talc and calcite and quartz, these are three phases. Tremolite is fourth phase. The degree of freedom is equal to 0. Now one thing is to be exhausted here. After that only the reaction proceed. All are getting it now? Okay. 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 So talc plus calcite, either talc or quartz will be consumed. So here what happens at reaction 2, either talc or quartz will be consumed, because where talc comes from, where talc come from the previous reaction 1 ना, talc reaction 1 से आता है. अगर रिएक्शन 1 में ही talc कम फॉर्म हुआ है तो talc जल्दी खत्म हो जाएगा. अगर रिएक्शन 1 में talc बहुत ज्यादा फॉर्म हुआ है तो क्वार्ट्ज खत्म हो जाएगा. तो सेकेंड रिएक्शन में जो फॉर्म हो रहा है टाल्क प्लस कैल्साइट प्लस क्वार्ट्ज गिविंग राइज टू ट्रेमोलाइट. नाउ दिस टाल्क एंड क्वार्ट्ज आर प्रोन टू बी कंज्यूम्ड एंड इट डिपेंड्स ऑन द रिएक्शन 1. रिएक्शन 1 में अगर क्वार्ट्ज बहुत ज्यादा आ गया था तो टाल्क बहुत ज्यादा फॉर्म हो गया होगा. अगर रिएक्शन 1 में क्वार्ज ही कम था तो टाल्क भी कम होगा। तो अकॉर्डिंगली क्या होगा, यहाँ रिएक्शन 2 में फर्क पड़ेगा। रिएक्शन 2 में कौन पहले कंज्यूम होगा, टाल्क या क्वार्ज, उसी के ऊपर डिपेंड करेगा। तो रिएक्शन 2 में क्या होगा, ये डिग्री ऑफ फ्रीडम 0 है। अभी क्या प्रॉब्लम होगा कि सेम चीज विल कंटिन्यू, लाइक इफ talc will be either talc will be consumed or quartz will be consumed, then only degree of freedom is equal to 1. After that only the reaction can continue, considering that quartz is consumed. Okay, considering that quartz is consumed, then again talc will react with only calcite without quartz, and it will form dolomite plus tremolite plus CO2 plus H2O is common. Again talc will react with only calcite and it will form dolomite and tremolite. See, in presence of quartz, talc plus calcite is forming tremolite, but in absence of quartz, talc and calcite is forming dolomite plus tremolite. Okay, so this is the thing. Like that only, all the reaction will be proceed. Okay, all the reaction will proceed. These are only things written. Okay, all the reaction will proceed like that only, like your yeah, this is the end of like your 0.7 less than 0.7. You can write this thing, you can write this thing like the degree of freedom becomes 0, one phase is to be consumed or one phase is to be exhausted, like that. The degree of freedom is equal to will be 1, and that's how will be the reaction will proceed further. And for this case this will be consumed first, for that case that will be consumed first. Okay, I have told you for which case which will be consumed. Okay, it is also written here. Okay, this is the, yes Surabhi, are you saying anything? Okay, so this is the reactions for XCO2 less than 0.7. Likewise, this is the SF diagrams. Okay, you can see here. I am just getting one example. After that, you can understand. Okay, here dolomite and SiO2. This is talc. Okay, this diagram changes to this. Okay, see this dolomite talc line is there. Dolomite talc line is there, but this line changes to this. This line changes to this thing. This dolomite plus dolomite quartz line changes to this. So you can write it down like dolomite plus quartz. Okay, what it will give? Calcite. It gave calcite and talc because this line changed to this. So calcite plus talc. It gave calcite plus talc. This is how we study the SF diagrams. Okay. Okay. See here the reaction is also written: dolomite plus quartz, talc plus calcite. Understood? Okay. Going to next, when the XCO2 is like 0.7 to 0.97. Okay. Now what will happen? Dolomite plus quartz will directly give tremolite, and this reaction will continue until and unless one phase is consumed. After quartz is consumed, then tremolite will then dolomite will react with talc. Sorry, as long as CO2 CO2 0.97, the next potential reaction encountered as temperature increases dolomite plus talc. Okay, let me see the grid diagram. This is the first reaction, na? Dolomite plus quartz it gives tremolite plus calcite. After that, tremolite plus calcite will give dioxide. That should be the reaction. Okay, so let's skip this thing. Just 0.97, 0.7 to 97. Skip this thing. And after that, greater than 0.97 will be dolomite plus quartz will be directly giving dioxide. Okay, then dolomite plus tremolite. Okay, XCO2 less than 0.63 phosphorite may be introduced. So this is not important. This is XCO to 0.63 greater than 0.63. This is not important. You just memorize, just remember this three things. Okay, less than 0.7, 0.7 to 0.97, and greater than 0.97. These three will be important. Okay, this is not. Okay, everyone got it, like the 0 point less than 0.7, everyone got this thing, or anyone has having any problem? So likewise in the closed system behavior, we can see here. See, dolomite plus quartz will give talc plus calcite, and as quartz is consumed, this talc plus calcite will directly form tremolite plus dolomite. Okay, as quartz is consumed, this talc will directly react with calcite and it will form tremolite plus dolomite. Okay. For initial composition, dolomite plus calcite plus quartz marble at low temperature again begin to heat in a contact area at 3 km depth, XCO2 0.5 under closed system condition. The first reaction encountered is reaction 1. Talc plus calcite is produced at equilibrium. C is equal to 5 because now component is 5. Now component C is equal to 5 because H2O and CO2, these are not in mobile phase, these are included in the system, these are not circulating. Okay, so C is equal to, that's why C is equal to 5. Earlier C was 3 na, because now the fluid components are no longer perfectly mobile. Phase 5, reaction 1 takes place at equilibrium, F then equals to 1 at a fixed pressure, and the reaction is a continuous reaction in which the composition of the fluid is buffered along the reaction curve toward higher values of XCO2 as temperature. Yes, so that's the thing. So here what happens, reaction is a continuous reaction, reaction hota jata hai, and this XCO2 increases. Okay, XCO2 increases as reaction proceeds. Okay, as reaction proceeds, SiO2 continuously replaces CaCO3. Now from this CaCO3, CO2 will be, CO2 बाहर निकलेगा कि नहीं, ये जब रिप्लेस करेगा क्या करेगा, रिप्लेस करता जाएगा, टाल्क फॉर्म होता जाएगा. ठीक है, टाल्क फॉर्म होता जाएगा, Mg SI Mg2 Si4 O10. यहाँ पर CO2 जो है, CO2 क्या होगा, लिबरेट होता जाएगा. ठीक है, CO2 will be liberated. Now this thing will happen, CO2 will be liberated, and your the CO2 XCO2 will increase. XCO2 will increase. That's the thing that is saying. Okay, the mineral assemblies can buffer fluid, and that's only, nothing else. Now the, like, you can proceed the reaction like the 0.5 open system. The main thing is the CO2 will increase first. Okay, the CO2 will increase first, that's the thing. Okay, this is the closed system behavior. Closed system behavior, nothing much in closed system behavior. The main thing important is open system behavior. Closed system behavior, just read it out, you will understand. Nothing much more to make you understand here. Okay. Okay, closed system versus open system, you go through this thing. What is the difference between closed system behavior and open system behavior? Then I am going to the regional metamorphism of siliceous dolostone. This is not much more important, but I am just telling you. Okay, this thing, just I am telling you the diagram, grid diagram. Okay, you can see here. This is 0.1. Okay, and this is your 0.87 something. Let me see what is the 0.8 is. 0.87, yes. So this is 0.87. Okay, so now in case of regional metamorphism, this is also dependent on temperature. Okay, also dependent on pressure, but we have taken 1 bar as constant pressure. Okay, that's why we are taking P plus F is equal to C plus 1 na? We have made this diagram in a constant pressure thing. Okay, so now there are three cases. that is less than 0.1, 0.1 to 0.87, and greater than 0.87. Okay, there are three cases. In case of less than 0.1, you can see these three diagrams, three lines. Okay, these three lines. These three lines are equivalent to that first one. Okay, that means you can see this first diagram, this thing. Okay, this thing is just, we have compressed this thing. Okay, you have compressed this thing. Okay, this is 0.1 for regional metamorphism. Okay, so for regional metamorphism, talc will be formed only in case of okay, pressure is 0.5 GPa. Sorry, not 1 bar. Pressure is for 0.5 GPa. In case of regional metamorphism, talc will be only formed if XCO2 is less than 0.1. Okay. If XCO2 is 0.1 to 0.87, the first formed mineral will be tremolite. If greater than 0.87 XCO2, the first formed mineral will be dioxide. It is the only difference. Only difference is the values. Okay. Other things are same: internally buffered fluid, externally buffered fluid, how the reaction proceeds, how the degree of freedom works. Degree of freedom helps to proceed the reaction. All the things are same. Okay, you just have to memorize these values. Okay, this will complete your progressive metamorphism of siliceous dolostone. I am writing out again. For contact, for less than 0.7 XCO2. Okay, XCO2 less than 0.7, the sequence will be talc plus tremolite plus dioxide plus phosphorite. For 0.7 to 0.97, the sequence will be tremolite plus dioxide plus phosphorite. Okay, not plus, next it is give arrow mark. Okay, for greater than 0.97, it will be dioxide, then phosphorite. Okay, for regional metamorphism, less than 0.1 will be talc plus tremolite plus dioxide plus phosphorite. 0.1 to 0.87, it will be tremolite plus dioxide plus phosphorite. For greater than 0.87, it will be dioxide, then phosphorite. This is the only difference. All other things are like closed system, how open system works, how closed system works, how degree of freedom plays a role to proceed the reaction. All the things are same. Okay, everyone got it? When XCO2 is very slow, very low, sorry, talc forms when XCO2 is like less than 0.1. Okay, this is the thing. Okay, you just go through this PPT. And metamorphic of calcilicate rocks, you just memorize this thing. There are 4 zones: ankerite zone, biotite zone, amphibolite zone, and joycite diopside zone. 5 zones, sorry. Okay, 5 zones. Okay, ankerite zone, ankerite, biotite, let me see, biotite, amphibol, joycite diopside. Ankerite, biotite, amphibol, joycite, and dioxide. This is not important for your long question or something. Dioxide, it is important for our GSI prelims. Okay, it is important for GSI prelims. In the previous year, it was directly, there was a question: what is the Facies assemblage of metamorphism of calcilicate? Directly there was a question. Okay. I think GSI prelim or the assistant hydrology question, hydrology, there in that only. Okay, that much for today. Okay, thank you.